Hello everyone. Today I am going to start inverse Laplace transform. It's very important topic. We know Laplace transform definition. F of t is a function of t for all positive values of t. Then Laplace transform is denoted by L of f of t and is defined as L of f of t is equal to f bar of s is equal to integral 0 to infinity, some formula is there. Now L of f of t is equal to f bar of s. If you send the L to this side, f of t is equal to L inverse of f bar of s. If you send the L to this side, L inverse of f bar of s. Now therefore L inverse of f bar of s is equal to f of t is called inverse Laplace transform. L inverse of f bar, that means inside of L inverse the function is in terms of s is equal to outside RHS side we will have f of t in terms of t function. L inverse of inside is in terms of s, RHS side is in terms of t. L inverse of f bar of s is equal to f of t. Now formulas, the L inverse called inverse Laplace transform operator. Now formulas, first we will recall all the Laplace transform formulas. From this only how to write all these formulas I will tell you. You have to learn all the 11 formulas of Laplace transform, all the 11 formulas of inverse Laplace transform. Also here all the formulas I have given already. Now L of 1 is equal to, now see inside of Laplace transform L of inside function is in terms of t, RHS side function is in terms of s, whereas in inverse inside of L inverse the function is in terms of s, whereas RHS side function is in terms of t. Remember, now from this how to derive these formulas. L of 1 is equal to 1 by s. L of 1 is equal to 1 by s. If you send the L to this side, L inverse of 1 by s is equal to 1. This is the formula. L inverse of 1 by s formula is 1. L of t is equal to 1 by s square. If you send the L to this side, L inverse of L to this side, L inverse of 1 by s square is equal to t. L of t square is equal to, we already know the formulas, already Laplace transform we learned. Now from this how to write these formulas, if you remember, you can remember this also. L of t square is equal to 2 factorial by s cube. If you send the L to this side, L inverse of 1 by s square, constants you cannot keep the constants inside of operators, Laplace or inverse Laplace transform operators. If you send the L to this side, L inverse of 1 by s cube is equal to t square by 2 factorial. Constants you have to write outside. L of t cube is equal to 3 factorial by s cube. Therefore, L inverse of 1 by s to the power of 4 is equal to t cube by 3 factorial. In the same way, L of t to the power of n is equal to n factorial by s to the power of n plus 1. L inverse implies you can write this L inverse of 1 by s to the power of n plus 1 is equal to like this. Now L of e to the power of at is equal to 1 by s minus a. If you send the L to this side, L inverse of 1 by s minus a is equal to e to the power of at. In the same way, another formula. In the same way, sin at, L of sin at is equal to a by s square plus a square. If you send the L to that side, L inverse of 1 by s square plus a square is equal to 1 by a into sin at. Constants you have to write outside. In the same way, L of cos at is equal to s by s square plus a square. Therefore, if you send the L to this side, L inverse of is equal to cos at, sin hat, cos hat, like this. Without learning all the formulas, you cannot do anything in inverse Laplace transform. By heart all the formulas, all the 11 whatever I have given without fail. Then only you can able to do the sums. Now, the inverse Laplace transform is more important than Laplace transform. Remember and learn and by heart all the formulas. Thank you. Now, we will do the problems. Find the inverse Laplace transform of the first one, second one, third one. Now, first one we will write L inverse of 2s minus 5 by s square minus 4. To do this one, first we will split into parts is equal to L inverse of 2s by s square minus 4 minus 5 constants outside we have to write s by 1 by s square minus 4. If you learn all the inverse Laplace transforms, you can do any problem very much easily. 2 constant outside, 2 into L inverse of s by s square minus 4. We can write s by s square minus, denominator is minus, means cos h 2t you will get, minus 5 into sin h 2t, s square minus 4, sin h 2t you will get. This is the answer of the first one. In the same way, L inverse of 2s plus 1 by s into s plus 1 is equal to L inverse of 2s plus 1. We can write as 2s plus 1, s plus 1. 2s plus 1 numerator we can write as s plus 1 by s into s plus 1. That is equal to, now if we split into parts, L inverse of s by s into s plus 1 plus L inverse of s plus 1 by s into s plus 1. S plus 1, s get cancelled. That is equal to L inverse of 1 by s plus 1 plus L inverse of 1 by s. L inverse of 1 by s plus 1 is e to the power of minus t. L inverse of 1 by s is 1. This is the answer. Now third one, L inverse of 3s minus 8 by 4s square plus 25. We will split into parts. L inverse of 3s by 4s plus 25. 4s square plus 25 minus 8 into L inverse of 1 by 4s square plus 25. Now in our inverse Laplace transform, in the denominator we don't have any formulas of 4s square or 3s square or 2s square or 5s square. Whatever may be denominator in Laplace or inverse Laplace. In Laplace or inverse Laplace, in the denominator contains only s square plus a square in the form or s square minus a square form. There is no 4s square or 3s square or 2s square like that. That's why we will take common 4 from the denominator. Now 3 already constant. I am taking common 4 from the denominator. I am taking common 4 from each denominator. 3 by 4 outside. S by s square plus 25 by 4 minus 8 by 4. I am taking common 4 from this also. From this also L inverse of 1 by s square minus 25 by 4. 25 plus only. Now that is equal to 3 by 4 into L inverse of s by s square plus 5 by 2 whole square minus 2 1 the 2 2 the 2 into L inverse of 1 by s square plus 5 by 2 whole square. Now that is equal to, we can write the formula 3 by 4 into L inverse of s by s square plus a square. S by s square plus a square is cos 5t by 2 minus 2 into 5 by 2. 2 into 5 by 2 is 2 into 5 by 2 sin 5t by 2. 2 into 2 is 4. This is the answer. Then the next topic is the first shifting theorem. In inverse Laplace transform, the next topic is first shifting theorem. Just like a Laplace transform, here inside of L inverse of f bar of s is equal to f of t. L inverse of f bar of s is equal to f of t. Then L inverse of f bar of s minus a, inside s minus a occurs, then you have to write outside e to the power of at into f of t. Just quite reverse like than previous one. F bar of L inverse of f bar of s minus a is equal to e to the power of at. Inside s minus a occurs, you have to write outside e to the power of at into f of t. Inside L inverse of f bar of s plus a occurs, you have to write outside e to the power of minus at into f of t. By had these two formulas. Based on these two formulas, I will do one problem. Then you can understand. The first problem is L inverse of 1 by s plus 2 whole square plus 16 is equal to, that is equal to L inverse of s plus 2 occurs. That's my f bar of s plus 2. Inside is s plus 2 whole square plus 16 is there. F bar of s plus 2. That is equal to, if you remove this s plus 2 e to the power of minus 2t into L inverse of f bar of s. That means I removed s plus 2. I removed s plus 2 means I will get e to the power of minus 2t, one extra term, into L inverse of f bar of s. E to the power of minus 2t into L inverse of f bar of s is how much? 1 by, I removed s plus 2. That's why this is in the form of s square plus 16. In place of s plus 2 is there. I removed s plus 2 outside. Therefore, this is in the form of s square plus 16. That is equal to e to the power of minus 2t into L inverse of 1 by s square plus 16 is s square plus 16 means sine 40, 1 by 4 sine 40. This is the answer. Wherever inside s plus 2 is there, we have to write outside e to the power of minus 2t. Now the second one is L inverse of, the next one is L inverse of 2s plus 3 by s square plus 2s plus 2. Now to do this problem, what we have to do is, we will write that is equal to L inverse of 2s plus 3, we can write as L inverse of 2 into s plus 1 by s square plus 2s plus 2, we can write as s plus 1 whole square plus 1. Now if you want, you can check 2s plus 2 plus 1, 2s plus 3. Numerator is in the form of 2s plus 3. I wrote in this form. That is equal to L inverse of, before that s plus 1, I remove s plus 1 outside, so that e to the power of minus t. I am removing s plus 1 outside, e to the power of minus t into L inverse of, you will get a 2s plus 1 by s square plus 1. I removed s plus 1 outside, so that I wrote e to the power of minus t outside. Now in place of s plus 1 I removed means 2s plus 1 by s square plus 1. That is equal to e to the power of minus t into, I will split into parts, L inverse of 2s by s square plus 1 plus L inverse of 1 by s square plus 1. That is equal to e to the power of minus t into 2 s by s square plus 1 is cos t plus L inverse of 1 by s square plus 1 sin t. This e to the power of minus t is for the whole. 2 cos t plus sin t. This is the answer. Now once again I will tell you, 2s plus 1 I wrote in this form. As a denominator I wrote in this form. I removed s plus 1 from inside to outside, e to the power of minus t, so that the inside part becomes like this. After that, from here as usual part I split it and I applied the suitable formulas. Thank you.